Hello, welcome to this walkthrough of a ladder problem relevant to the mechanics section of the current A-level syllabus. This is an old M2 problem, an Excel problem, which I took from physicsandmathstutor.com. Let's have a look. So we've got a ladder, AB, length 4A, one end resting on a rough horizontal ground, the other end rests on a smooth wall. There's a mass of 3M fixed on the ladder at C. AC has a length A. The ladder is modelled as a uniform rod in a vertical plane perpendicular to the wall. So this is perpendicular, you've got a right angle there, as you would always have with these problems. The ladder rests in a limiting equilibrium, making an angle of 30 degrees with the wall as shown in the diagram above. We're going to find the coefficient of friction. Let's have a look. Well, let's start on this. I've just got another diagram here I'm going to annotate. So what have we got? I'm just looking. I've got masses, haven't I? I've got a load of mass, 3M there. That's 3M. Oh, the ladder is uniform, so that means the mass will be 2A along, is uniform, and it's a mass of M. So that's going to be 3mg. That's going to be just mg. Well, what else do we have? We have friction there, and it's in limiting equilibrium. So I know that's going to be equal to mu r, that friction. And here I've got a reaction force, a normal reaction force. So that is mu r, and then that's the r. Up there I've got another reaction force, but can't call that R because it's different to that one. I call it N. I always use N for that one. So let's first do the forces. Well, what do we have force wise? I've got N equals mu R. That's working left to right. N goes that way, mu R. There's no other horizontal forces. My up and down situation is I've got a reaction force going up, and I've got 3mg going down plus mg going down. So it looks like that the reaction force is 4mg. I can then say, well, I can get rid of that n because mu r, well, I could write that as, so I could get rid of the r, I could say N equals 4mg mu, which will come in handy at some stage. So what do we then do next? Well, with these problems we resolve forces, but we also take moments. Now we've got an interesting diagram here. There's a bit going on. My anti-clockwise, I'm going to take moments about, well, that should be called A actually, and that should be called B. So I'm going to take moments about A. If I can do, I prefer to take moments around A, which is the base of the ladder, just because it gets rid of this R and this mu R, which makes things easier most of the time. Anti-clockwise, so these would take it clockwise relative to that pivot. That would take it anti-clockwise. So I've got that N force which is going anti-clockwise. So let's have a look. We've got N times, now I want the perpendicular distance of this. So if you look here, line goes across. Where can I hop off and go perpendicular to the pivot? If I went from there, I could hop off here, and that, what I'm showing you there, is the perpendicular distance. Hard concept sometimes this is, and it's something to practice. So you see here, that is the perpendicular distance from N. Now that's part of the triangle. So if I take this 30 degrees here, it's going to be, and that's 4A, it's going to be the cos component, so it would be 4A cos 30. Now that's the only anti-clockwise. I've got this clockwise, and that's going down. Now the perpendicular distance will be just this bit going across. So I'd have 3 mg times a sine theta. That's a sine theta, that's the, sorry, sine 30, I apologise, sine 30. So you'd have a little 30-degree angle there. Plus for this one, it's just going to be 1 mg, just the mg, and that would be mg times 2a sine 30. Because this force going down there, imagine there's a 30-degree angle there, it's the sine component with a hypotenuse of 2a. Again, work on your trig, work on your perpendicular distances. Let's tidy this up a bit. We've got a everywhere. The length, the actual length doesn't matter, it's just what proportion of the length we have. So I've got 4 cos 30. Cos 30 is root 3 over 2. So root 3 over 2 times 4 is 2 root 3. So 2 root 3 times n. What do we have here? We have 3 mg, and sine 30 is a half. So I've got 3 over 2 mg plus I've got 2 over 2, half of 2 is 1, so I've got mg. So we're just simplifying this. Sine 30 is a half, cos 30 is root 3 over 2. So what do I have here? I have 5 over 2 mg, if I simplify it further. Well, what is n? 2 root 3 times, and n we can see up here is 4mg mu. So this comes in handy. It's a combination of taking moments and resolving forces. Notice I've got an mg there. It's nice to cancel this stuff out. 4 times 2 is 8, so I've got 8 root 3 lots of mu equals 5 over 2. And as you can see, we are getting there, aren't we? So I can then simplify. Let's have a good look. 5 over 16 root 3 is your mu. That's your coefficient of friction. If I multiply top and bottom, you don't need to do this in mechanics as much that people aren't too bothered about the root 3 in the bottom when we're doing mechanics. But if you're a pure mathematician, you like to do this. Multiply top and bottom by root 3. You get 5 root 3 over 48. And that is your final answer. And there you go. That is how you get... Look at the question again, sorry. That's how you get the marks. It's 10 marks there. 10 marks got if you can resolve forces and you can take moments, understand your trig, understand your perpendicular distance, you've got 10 marks there. I really hope that's clear. I think that's a very good example for you to go through. Good luck.